In 1946, moviegoers got their first glimpse of an astonishing new machine.
Are people becoming obsolete? A giant electronic brain has started cogitating at the University of Pennsylvania. It's made of vacuum tubes, like your radio, and it can add up a column of figures a yard long in a second. It's the world's first electronic computer. Right now, it's solving mathematical problems for the U.S. Army, but who knows? Someday a machine like this may check up on your income tax.
Imagine a time when the word computer referred to massive machines operated by teams of engineers, powered by vacuum tubes, and programmed with punch cards. From these room-sized behemoths to smaller, faster, and more reliable systems, the journey of computing during the 1940s to 1960s was a revolutionary period that laid the groundwork for the digital world we know today. Hi, I'm Majdi El-Jazmawi from AIVirtus. I'm a computer engineer, and today I'll guide you through the critical developments in computing from the 1940s to the 1960s. From the ENIAC to integrated circuits, we'll explore the machines, people, and innovations that set the stage for the technological revolution to come. Let's dive in. The era of vacuum tubes. The 1940s marked the dawn of electronic computing. At the forefront was the ENIAC, Electronic Numerical Integrator and Computer, completed in 1946. Built at the University of Pennsylvania, the ENIAC weighed 30 tons, consumed as much electricity as a small town, and used 18,000 vacuum tubes. Despite its size, it could perform 5,000 additions per second, a groundbreaking achievement for its time. In Germany, Konrad Zuse was developing machines like the Z3 in 1941, which became the first programmable digital computer. Unlike the ENIAC, the Z3 used electromechanical relays and demonstrated the viability of automated computation through binary logic. The concepts of stored programs, which we take for granted today, were formalized by John von Neumann. His architecture, introduced in 1945, proposed that both program instructions and data could be stored in the same memory. This laid the foundation for all modern computing systems.
In 1946, Johnny asked me if I would join him at the end of the war in Princeton and help him to carry out in concrete form the ideas which he had been working on in 1944 and 1945. Of course, I jumped at the chance. We rushed to Princeton and got started. The machine that eventuated from that is the one you see here, and it contains essentially those things which the modern computer has in it, although in somewhat primitive form. This machine has stored program concept as its major feature, and that, in fact, is the thing which makes the modern computer revolution possible.
Many people have wondered how Johnny von Neumann could think so fast and so effectively. How he could find so many original solutions in areas where most people did not even notice the problems. I think I know a part of the answer, perhaps an important part. Johnny von Neumann enjoyed thinking. I have come to suspect that to most people thinking is painful. Some of us are addicted to thinking. Some of us find it a necessity. Johnny enjoyed it. I even have the suspicion that he enjoyed practically nothing else. This explains a lot, because what you like, you do well. And he liked thinking, not just in mathematics. He liked thinking in the clear and complete manner of mathematicians, in every field. This also explains his effectiveness in connection with computing machines. Because computing machines apply logical processes to fields, not only mathematics, but to others as yet untouched by the logical process. And it is very significant that this revolution, the revolution of the electronic brains, was practically initiated by John von Neumann.
The transition to transistors. In 1947, the invention of the transistor by Bell Labs changed the trajectory of computing. By the 1950s, transistors replaced vacuum tubes, making computers smaller, faster, and more reliable. One of the first commercially successful computers was the UNIVAC-1, Universal Automatic Computer, developed in 1951 by Remington Rand. It was used for business applications and famously predicted the outcome of the 1952 US presidential election. Unlike earlier machines, the UNIVAC used magnetic tape for data storage, marking the transition away from punch cards. Around the same time, IBM entered the scene with the IBM 701 in 1952, the first in its line of business-oriented machines. This was followed by the IBM 704 in 1954, which introduced hardware support for floating-point arithmetic, crucial for scientific calculations. On the software front, Fortran, means formula, emerged in 1954 as one of the first high-level programming languages. It enabled scientists and engineers to write instructions in a more human-readable format, accelerating the development of complex software systems. Integrated circuits and scaling power. The 1960s marked a turning point with the invention of the integrated circuit in 1958 by Jack Kilby of Texas Instruments. By the early 1960s, integrated circuits, or what we call it today, chip, allowed multiple transistors to be packed onto a single chip, dramatically reducing the size, cost, and energy consumption of computers. This innovation led to machines like the CDC 6600, designed by Seymour Cray in 1964. The CDC 6600 was the world's first supercomputer, capable of performing up to 3 million instructions per second. It was used for scientific research, including weather simulations and nuclear physics. Another innovation was the PDP-8, introduced by Digital Equipment Corporation in 1965. As one of the first mini-computers, it was affordable for smaller businesses and universities, making computing more accessible. Storage technology also advanced during this time. IBM introduced the first hard drive in 1956, the IBM 305 RAMAC, which could store 5 megabytes of data and weighed over a ton. If you're enjoying this dive into computing's early history to understand the past and future of AI, like this video and subscribe to AIVirtus. Share your thoughts on which invention from this era you think was the most revolutionary. The period from the 1940s to the 1960s was a time of incredible innovation. From the massive vacuum tube machines like ENIAC to the groundbreaking transistor-powered systems and integrated circuits, these developments laid the groundwork for the computers we use today and for today, AI. Again, I'm Majdi El-Jazmawi from AIVirtus. Like, subscribe, and share this video if you found it insightful. Let's continue exploring the history and future of AI together.